Hi, this is Mr. Mack. Now, this is the concept videos on the quadratic formula, using the quadratic formula, the discriminant, and then the nature and number and type of roots. Now, it's my plan to actually make two videos. The first video will discuss the quadratic formula and how we actually got it, and then how to use it. And then the second one, we will examine the quadratic formula in more detail and take a look at what the quadratic formula will tell us about the answers we would get from a particular quadratic equation. Okay, so first, where do we get the quadratic formula? Well, somebody had the bright idea after completing the square was known to say, well, what if we just had the general quadratic equation ax squared plus bx plus c equals 0. Now, a, b, and c at present are not known, but what we're going to do is we're going to solve this quadratic equation without really knowing what a, b, and c are by completing the square. Now remember, when you complete the square, first of all, we need to take the constant and move it to the other side. So we get ax squared plus bx and a blank and then equals c. And then we want a 1 in front of the x squared. So we divide through by a. Now that gives us x squared plus b over ax equals negative c over a. At this particular point, we're ready to complete the square. Now, we have the x squared and the x term on the same side. We have the constant on the other side, and we have a 1 in front of the x squared. When we have that, what we do is we take half of the linear coefficient, which is b over a. Now that gives us b over 2a. Now b over 2a, we're going to square that, and we want to add that to both sides of the equation. So if we square b over 2a, we're going to get b squared over 4a squared. And so that's what we'll want to add to both sides of the equation. Now, to continue then, this right-hand side, we really do need to take these two fractions and add them together. And if we do want to add these two fractions together on the right-hand side, then we need the same denominator. Now notice, negative c over a has a factor of a in the denominator. B squared over 4a squared has a factor of 4, a factor of a, and another factor of a. So I need another factor of 4 and another factor of a in the denominator of negative c over a. So I can multiply that by 1 in the form of 4a over 4a. And that'll give me both fractions having 4a squared for the denominator. Now, when I then multiply them together, I get b squared minus 4ac all over 4a squared for the right-hand side. Now remember, when you complete the square, what you get then is a trinomial that can be expressed as a binomial that's a perfect square. So x squared plus b over ax plus b squared over 4a squared actually becomes x plus b over 2a squared. Now remember, the first term in the binomial is the square root of x squared. The last term in the binomial is what you square to get b squared over 4a squared. Well, we squared b over 2a to get b squared over 4a squared, so it's b over 2a. And then we take the sign of the middle term, which is plus, and so we get x plus b over 2a quantity squared is equal to b squared minus 4ac over 4a squared. Now, the next step in completing the square process is to take the square root of both sides. So the square root of x plus b over 2a quantity squared is x plus b over 2a. And then on the other side, we get the square root of b squared minus 4ac all over 4a squared. And remember, when we take the square root of both sides, you've got to add a plus or minus sign on one side or the other. We choose to put it in front of the square root. Now, I'm going to point out to you that this is plus or minus the square root of b squared over 4ac, minus b squared minus 4ac over the square root of 4a squared. But the square root of 4a squared is 2a. Now, to solve for x, I have to subtract b over 2a from both sides. So I get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now, since these two fractions both have a denominator of 2a, we can add their numerators together, and what we get is negative b plus or minus the square root of b squared minus 4ac over 2a. Now, this is a very important result, and it has been known through the centuries as the quadratic formula. So x is equal to negative b plus or minus square root b squared minus 4ac over 2a is the quadratic formula. Now, guys, this must be committed to memory. There are a number of different memory devices. You can sing this to the Pop Goes the Weasel song, or there are other memory devices. I'll sing it once, but that's it, okay? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you do have to remember that the whole thing is over 2a. Now, how do we use the quadratic formula? Well, if we take the quadratic formula oops, let's go to a new page. If we take the quadratic formula and we have a quadratic equation, let's imagine, for example, that we have the quadratic equation 6x squared minus 17x plus 10 equals 0. We can use the quadratic formula to solve this quadratic equation by just plugging in numbers. In other words, 6 is going to be equal to a, negative 17 is going to be equal to b, and 10 is going to be equal to c. So we write x is equal to 17 plus or minus the square root of negative 17 squared, that's 289, minus 4 times 6 times 10, all over 2 times 6. Okay, now, we've got some work to do here. 4 times 6 is 24. 24 times 10 is 240. 289 minus 240 is 49. So we get 17 plus or minus the square root of 49 over 12. Now the square root of 49 is 7. So that tells us that x is equal to 17 plus 7 over 12, or 17 minus 7 over 12. Now 17 plus 7 is 24, and 24 divided by 12 is 2. And 17 minus 7 is 10, and 10 divided by 12 is 10 twelfths, or 5/6. And so we're using the quadratic formula to solve the equation 6x squared minus 17x plus 10 equals 0. And that's the way that one goes. Now notice, in this particular case, we got rational zeros. We got 2 and 5/6. Now what that means is that this equation could actually have been solved by factoring. But some of the others that I'm going to use as examples won't be as easy to solve. Let's take a look at the second example. Oops, let's go back here. I'm going to go ahead and see if I can't keep the quadratic formula. There we go. Now, the second example I get is 0 equals x squared minus 2x minus 1. Here, a is 1, b is negative 2, and c is negative 1. So now we get x is equal to 2 plus or minus the square root of 4 minus 4 times 1 times negative 1 all over 2 times 1. Now we have some work to do here. We have 2 plus or minus square root. Now 4 minus negative 4 is 8 over 2. Now, I need to simplify the square root of 8. And what I want to know is what's the largest factor of 8 that's a perfect square? Well, 8's largest factor that's a perfect square is 4. So I could write the square root of 8 as the square root of 4 times 2. And then you could take the square root of 4, that's 2, and the other 2, which isn't a perfect square, stays inside. So we get 2 plus or minus 2 square root 2 over 2. Now guys, you can only simplify fractions if you can cancel factors. But in this case, there's a factor of 2 in the numerator, and there's a factor of 2 in the denominator, and those 2's can be factored, so you have 1 plus or minus square root 2 for your answers on this one. Now notice you get irrational answers here. It wasn't all that difficult, but you do get irrational answers. So this one would not have factored. You could have completed the square, but it wouldn't have factored. All right, now one more example here. Sometimes, and this is why we get to the point where we need complex numbers, you will not get real solutions. So let's try x squared minus 4x plus 13 equals 0, of course. Now in this one, a is 1, b is negative 4, and c is 13. So using the quadratic formula, we get x is 4 plus or minus the square root of 16 minus 4 times 1 times 13. That's 52 all over 2 times 1. Now 16 minus 52 is negative 36. So we get x equals 4 plus or minus square root negative 36 over 2. Now you learned in an earlier section that when you have a negative sign under a radical, it comes out as an I. So this becomes 4 plus or minus I radical 36, and then of course the square root of 36 is 6. So we get 4 plus or minus 6i over 2. And since there's a factor of 2 in the numerator and in the denominator, you can factor the factor 2 out of the numerator and cancel that with the 2 in the denominator. So we get 2 plus or minus 3i. Now that's the quadratic formula, how we got it, and how it's supposed to be used. Just one more thing. Remember now, before you use the quadratic formula, your equation has to start out in standard form. You need the x squared term, the x term, the constant equals 0. If you don't have it in that standard form, then your attempts to use the quadratic formula are doomed to failure. And that ends the video on the quadratic formula and how to use it. I'll be back with what it tells us about the roots in the next video.